So my name is Frederic. I work at Red Hat, and usually I work on pretty much everything Kubernetes and observability. That means mostly Prometheus. And today I want to talk to you about something called continuous profiling. But before we jump into that actual topic, let's look at why this could be useful. So as I said, I work on Prometheus, and so we'll see how this fits into the Prometheus ecosystem broadly. So we get an alert from our system, and it says there is a particular workload that is crashing often. And so we go ahead and we look at Prometheus, and Prometheus can tell us the query that has caused this alert. And we see that coming up over here. And we see, okay, let me make this a little bigger. We see, okay, this is the pod that has this particular problem, right? So we go ahead, and there are some other metrics that can tell us, okay, the last termination state, reason, and Prometheus can tell us that as well, if we ask it which one is the currently active one. And we get that answer as well, and it's telling us this particular workload is being killed. And if you're not familiar with what this means, it means that our program has tried to allocate more memory than the system has given it to allocate in whole. So that means, often this means that we have some sort of a memory leak. So when we have such a situation, we often can see a very continuous pattern of memory usage. So let's have a look at that, working set bytes. And because Kubernetes labels it this way, we can look at that as well. So this is a very typical graph for when you have a memory leak. Memory ramps up over time, and once it's hit that memory limit, the operating system kills the process, and the process gets restarted because that's what Kubernetes does, and everything happens all over again. So when we're in a situation like this, our process has already died, but we know it was an kill. So what we usually want is a memory profile from one of these peaks. And Go luckily gives us a set of really awesome tools to take profiles like this. However, typically, we want to have a profile after the fact, after this has happened, right? So this is where continuous profiling comes in. So imagine a Prometheus-like system that continuously goes to your program and captures profiles over time. So next time, when we actually have a memory leak and we're being out of memory killed, we could go back in time and look at a profile right before this happened. And that's exactly what I created with a project that I called creatively conprof, continuous profiling. And it actually reuses a lot of idioms from Prometheus. It literally reuses the storage engine. It literally has the same query language, same service discovery, so that we have consistent metadata, and I'll prove that right now to you. So I'll take that query that I did against Prometheus with this selector, and once I query it, I should see, okay, we're not getting it right now, but basically what we should be seeing here is a list of profiles over time, and we can click on one of those profiles, and the pprof UI would pop up, and we could look at these profiles over time. And this has actually been proven to be useful in our production infrastructure already. But this is actually totally not new at all. Google has been doing this for years. They've written a lot of really cool white papers about this, about sampling strategies, about how they do this internally. And really, all I wanted to do with this project is give this possibility to the rest of us and have it open source. But I think even though the state that this project is in, it's already useful and it's proven to be useful for my team, there's a lot more super awesome analysis that we can do with this. So if we now continuously have all of these profiles over time, not only can we look at certain snapshots in time, we can also analyze them over time. So if we have consecutive profiles of the same process, we can even analyze which parts of our program have accumulated this memory and potentially caused this out-of-memory kill. So not only does this give us a diagnostic tool, it can also make suggestions about, hey, engineer, this is where you should look first if you're trying to solve this issue. So I think this doesn't actually exist in this program, so I encourage everyone to join me in the development of this project. We're actively working on this. And it's not going forward. But this project is called Conprof, so C-O-N-P-R-O-F. On GitHub, it's the same. The project name is the same as the organization, so go check it out. Thank you.